Good afternoon, and welcome to NASA's John C. Stennis Space Center in South Mississippi, where in just a few minutes you will have the opportunity to view a hot fire test on this RS-25 rocket engine. I'm Paul Foreman with the NASA Office of Communications here at Stennis Space Center. I visited the A1 test stand a few days earlier to get a better look at RS-25 developmental engine 0525, which today is scheduled to be tested for 500 seconds, or just a little more than 8 minutes. The RS-25 engines being tested at Stennis will help power NASA's Space Launch System, or SLS rocket, which is being built for missions beyond low Earth orbit, carrying crew and cargo to the moon and beyond. But many viewers may be asking themselves, what is an RS-25 engine? Let's take a look at a short video that will better explain this engine.
So, exactly what is the RS-25 engine? This amazing engine will be part of NASA's Space Launch System, which will be the most powerful rocket in the world, and will send our astronauts to the moon and eventually to Mars. NASA has 16 RS-25s with plans to build more, and each SLS rocket will have 4 engines. These engines are big, really big. The RS-25 is 14 feet tall and 8 feet in diameter. That is about the size and weight of a compact car, or 2 F-15 jet engines, and produces 8 times more thrust. Along with the 2 solid rocket boosters, the RS-25 engines will power the SLS at speeds of 17,500 miles per hour. That's 73 times faster than an Indy 500 race car. For 3 decades, the RS-25 helped propel the space shuttle into orbit. These engines have been modified and upgraded for their bold new mission, and are being tested at NASA's Stennis Space Center. These big, beautiful engines are designed to send astronauts on future missions beyond Earth's orbit and advance American leadership in space. To learn more about the RS-25 engine and NASA's Space Launch System, go to nasa.gov/SLS.
So there you have it. The RS-25 is the same engine used to propel the space shuttle into orbit for more than 3 decades. However, this engine has had several modifications to include a new flight controller that serves as the brain of the engine and 3D printed parts which are more cost-effective to produce. As we get closer to test time, it's important to know that a lot of work has been going on in preparation for this test. The RS-25 engine for this test was installed on the A1 test stand on July 23rd. Installing the engine into the test stand involves a team of highly trained technicians conducting a well-choreographed sequence of maneuvers to lift the engine from the transport vehicle and position it precisely in place. This time-lapse video condenses hours of work into just a little more than a minute, giving you a snapshot of the tremendous effort required just to get the engine in place on the test stand. Once installed, a team of engineers and technicians began the laborious task of making all the necessary connections, checking seals, valves, and myriad of other components to ensure everything is in proper working order. They will also install the various sensors used to capture the required data from the test. There are literally hundreds of details that must be in place and just right in order to have a successful test. On test day, engineers in the Test Control Center are going through their checklists, making sure everything on the engine and on the test stand is correct. Of course, the safety of our people and the RS-25 engine is the first priority, so there's always the possibility of a delay. We should be getting close to test time now, so let's switch over to live coverage of the sights and sounds of the A1 test stand of today's hot fire test of an RS-25 rocket engine. You just witnessed the awesome power of an RS-25 rocket engine for NASA's Space Launch System. The engineers in the Test Control Center are now going through their checklist to safe the engine and the test stand. We had a special visitor with us today at NASA Stennis Space Center. NASA Administrator Jim Bridenstine got to witness his first rocket engine test. Jim, could you tell us a little bit about what you've experienced here at Stennis today?
Absolutely. Thank you so much. This was an amazing test of an RS-25 rocket engine. I want to say congratulations to all the folks at Aerojet Rocketdyne that developed this rocket, and of course I want to thank the folks here at Stennis that just tested it. This was really a new and unique experience for me as the NASA administrator. I've seen lots of launches as a member of Congress before and now as NASA administrator, but the rockets always leave. In this particular case, the rocket stayed, and it stayed for 500 seconds of just a heart-pounding thrust that I could feel all the way inside my body. That was an amazing moment to watch, and I think it's important for everybody to know that what the RS-25 represents is America's ability to fly deeper into space than we've ever flown before. In fact, this is our opportunity to follow through on the President's Space Policy Directive 1, which says that we're going to the moon. This is the rocket engine that we're going to use as the core stage of the SLS rocket, which is the most powerful rocket that's ever been built, the biggest rocket ever been built with the exploration upper stage, and ultimately it's going to carry heavier payloads and bigger payloads than we've ever launched before. And in fact, it's going to help us build our next platform around the moon. So this is a great test. And what we just witnessed was the test of a single RS-25. There's going to come a day in the near future where we're going to put 4 of them together and we're going to test it on the B1 test stand with a liquid oxygen tank and a liquid hydrogen tank. In fact, the entire core stage of the Space Launch System, again, the biggest rocket ever to launch, is going to test right here at Stennis. And I can only imagine, given how intense that was with just 1 rocket, how intense it's going to be with 4 rockets. And of course, even more amazing is when we get this rocket to the pad and we launch it and we go to the moon. We're building an architecture that is going to be sustainable. The President says we're going to go to the moon, but not just the moon. He wants to go in a sustainable way, which means we're going to build architecture that our international partners can participate in, that our commercial partners can participate in, and we want every piece of this architecture to ultimately be reusable. And the Gateway is a big piece of that. And at the end of the day, the Gateway is going to be delivered by this amazing capability, the first piece of which we just tested behind me today. So what an amazing day. Congratulations to everybody involved. This was just a tremendous opportunity for NASA, and once again we've proven that the United States of America is the preeminent spacefaring nation in the world, and of course we want to maintain that preeminence. So awesome. Thank you for having me.
Thank you very much for joining us, Jim. We're going to close out today's program with some replays of today's test.